Hello everyone and welcome to this video on magnetic crack detectors. I am Mohammad Adnan Hassan, a pre-final year mechanical engineer studying in Madras Institute of Technology. So magnetic crack detectors are also referred to as magnetic particle detectors. These are purpose-built with either permanent magnets or electromagnets. Now based on this, they may be either called magnetic crack detectors or electromagnetic crack detectors respectively. Now, these use two non-destructive methods. First is the magnetic flux leakage testing, and then the visual testing. So, most commonly used is for final inspection, receiving inspection, in-process inspection, quality control, maintenance, and more. Now, the magnetic crack detector is based on the magnaflex test, which is also known as the magnetic particle inspection. Now, this is used for detecting cracks, slabs, seams, voids, pits, subsurface holes, other surface and slightly subsurface discontinuities. Mostly in not mostly all, only in ferromagnetic materials such as iron, nickel, cobalt, and some of their alloys. Now, the magnaflex test can be easily performed on raw materials, billets, finished and semi-finished materials, welds, and in-service assembled or disassembled parts. Now, obviously, question arises why magnaflex tests should be done in the first place. Now, for say an industry such as the automobile industry, the parts that are manufactured must withstand a thorough testing of integrity. Now, the test must be done in such a way that it does not damage the part or destroy it. So, a systemic examination was developed, which was known as the non-destructive testing, and within those series of tests, one is the magnaflex test. So the principle of operation of magnaflex test is pretty simple. It uses magnetic field lines passing through metal to detect any defects in the surface. So obviously, as if you can see here, it's a bar magnet with two poles. Pole is the place where the magnetic line of force exits or enters the magnet. North pole is where the magnetic line of force exits the magnet, and south pole is where the magnetic line of force enters the magnet. So that's a pretty simple concept. Now, if you break a bar magnet into say two parts, then each part acts as its own bar magnet with its own north and south pole. But say if it's not entirely broken apart, but like there's a crack in the middle, then within that crack acts as a secondary magnetic poles inside the like in the bar magnet. So each edge of the crack will act, say like one edge will act as a south pole and the other edge will act as a north pole. So and they will function as a secondary magnetic pole. Now when the magnetic field lines pass, we all know the magnetic field lines inside the bar magnet pass from the south pole to the north pole. So when this magnetic field lines spreads out, uh, it encounters that small gap caused due to the crack. Then the magnetic field line spread out, like within the magnet they are extremely concentrated and like constrained within a small area, but when they encounter that aircraft they spread out wide, and that is basically the method of finding out the defect. So thus it appears to thus the magnetic field line appears to leak out of the material and is called as a flux leakage field. Now, if iron particles are sprinkled on a cracked magnet, then the particles will be attracted to both the poles of the magnet as well as the crack. So the poles are obviously easily distinguishable with the cracks, so there's no problem in that. Now, where the particles cluster is where the cracks exist, and we can use this to detect the cracks easily. Thus, the cluster makes detection easier. As you can see in this picture here, when no defect exists, the magnetic field lines are straight, as I said before in the previous slide. But when there is a crack present, the magnetic field lines would spread out, and the cracks would act as their own north and south pole, and the particles would get clustered there. Now, horizontal MPI machine, it is one of the most commonly used mass production inspection machine. Uh, if you can see the picture closely, it has a headstock and a tailstock with an inductor in the induction coil in the middle, which is used to change the orientation of the magnetic field by 90 degree. Now, this machine is used for a large scale inspection, and it's really time saving as compared to the next machine that I'm going to show you. The magnetic yoke is basically a handheld electromagnetic crack detector, which induces a magnetic field between two poles, like the two poles as you can see in the picture. The common applications used are for the outdoor use, remote location, and well inspection. But here you'll have to manually rotate the magnetic yoke in order to inspect area horizontally and vertically for the presence of discontinuities. Now, obviously, this has its own advantages and disadvantages. The advantages being is that it's handheld and could be used for remote location, but at the same time, for like large scale inspection, it's really time consuming. Uh, so the next is steps for the magnetic particle inspection. So first, the surfaces has to be cleaned thoroughly, and usually a solvent degreaser is used if the surface is oily, in order to remove the oil, other contaminants, and any visible dirt. And then the cleanliness is checked visually through visual inspection. Uh, and then they apply, and then the magnetic flux is applied by bathing the part in a wet fluorescent suspension solution, which contains iron oxide particles, and then the electric current is passed. In order to observe the part under UV lighting, it's placed inside a dark room enclosure, and then the UV light is applied. So the defects that appear actually appear in relation with the magnetic, and within the appear in relation with the direction of the magnetic field. After that, the part is demagnetized, and a thorough visual examination is done. So the part is accepted or rejected based on some pre-determined criteria, and the failed parts are isolated from accepted parts and tagged accordingly. So coming to the conclusion, the as you can see, the magnaflux testing is a really fast and reliable method, and which does not compromise the integrity or safety of the part that is to be tested. The horizontal MPI machines are suitable for large inspection and consume less time, but obviously are not portable. And then the magnetic yokes are used in remote location to check wells, and also where the AC supply is not available. Like it can run on DC supply, but also you have to keep in mind that the magnetic yokes are really time consuming when doing large scale inspections. So here are the references, and that's it. Thank you.